Welcome to this tutorial of Mesh2Surface for SOLIDWORKS. This tutorial is dedicated to the fit surface command, and I loaded a part which is it has planes and holes here which can be modeled with standard sketch tools, but we have a surface on the top which is freeform, and this is where our fit surface command will help. In order to get this fit surface command available, you need to actually have some selection on the current mesh. I will use the standard mesh selection tools, and in this example the best is if we just use the magic wand. I'll just click here, and as you can see, the software pre-selected this surface. Of course, you can improve your selection using the slider to get more, but if I see this is more of a plane here, so this is not what I want to have selected, I will reduce my sensitivity, and probably I will use a little bit of my manual tools to select area of interest. So this is all I need to continue and apply my fit surface command. I will press OK, and I need to have the mesh selected here so I can start the fit surface. What fit surface command does, it takes approximation of a plane, and then it fits this surface with the NURB surface. Why I say NURB surface? Because it has control points which by default are 10 by 10, and the user can actually play with the different values. You can press 20 and enter, and the software will actually refit the surface. Like the other tools, we have the analyzer, and you can see the deviation. By default, when you start, the user can see immediately the deviation between the surface and the underlying mesh. As you can see on the screen, I put this to 50 microns, and I can take a look of my results. Also, you can always switch to shaded mode to get understanding of the resulting surface. But now let's speak a little bit more about the parameters here. We can extend the surface. By default is 40%, but you can adjust this. And this is useful for the operation later if you have some kind of trimming or extend. And for example here, I probably want this a little bit more, so I'll leave it to 40%, and I'll press preview. The other option is that you can adjust the smoothness of the result, so you can play with the smoothness, but as you can see, the smoother you make the surface, the harder it is to approximate the underlying mesh. Another option is that how this planar surface is generated. We can tell the software to fit the best plane here, like in this example, and it will take the boundaries of this plane, and this is how this surface will be generated. But also, what you can say is that you want to be axis aligned. What it does, that if I place it in the standard views, you see that now the surface is much better aligned to the axis. But also, I can probably tell the software that I want perfectly aligned. As you can see, now the U and V points are exactly where they align to the coordinate planes. Let's take a look at the back view. This is how you can manually adjust your parameters here until you're happy with the result. But also we have an automatic detection option. What it does, that it starts from 10 by 10 resolution and starts increasing these values until the software reaches the target tolerance. In this example, I provide 100 microns, and if I press find, the software automatically, as you can see, increases the number of U and V parameters until it gets the results of 95% to be within this tolerance. And this is my final result. The reason you see different coloring is that my target tolerance has been set to 100 microns, but my deviation is to 50 microns. In order to get the proper view, I need to put them at the same values. Of course, you can just increase this, leave this to 50 microns, and we can make another try here. We can give the 50 microns target tolerance. And now, to be able to achieve this tolerance, the software will create much more number of U and V sections here to get this result. So the more you want to get within this tolerance, the more control points you introduce. Also, I have to say that the maximum number of control points that the automatic detection is 50 by 50, and then the software just give up and stop creating this surface. At any point, you can just press cancel and it will stop where it has reached. When you're happy with this, I can just press OK, and the surface will be created as a normal SOLIDWORKS surface. For the demonstration, I just created a post extrude shape here that I will right click and edit this feature. And actually, because this is after that, we cannot use it what I want. So I will just take this, will drag and put it before my boss extrude. I will take and edit my feature. So now, for this side, I can just tell the software that I want this to be up to the surface. Oops, sorry, this was the blind direction because it was here. But the other, I can just say that I want this to be up to this surface. As you can see, the software automatically created my boss extrude. If I just hide my shape, you can see that I created my body in a more complex way. And you can apply again your next step to create a fillets or reconstruct and continue building your project. I hope this is useful. Thank you for watching.